All right, today we're going to work on lesson 2.7 on using formulas. We're going to solve equations for specific variables. Today, the other part of the lesson is convert units of measure by applying properties of equality. That's really tomorrow. Today, we're going to really hone in on being able to take an equation and solve it for a specific variable. Okay, so first of all, the idea of a formula. Okay, when we start to solve these equations, some of them will be formulas. And a formula is an equation that expresses a relationship between certain quantities, and usually more than one of these quantities is an unknown, so we get multiple variables in a formula. We'll deal more with this later. All right, we're going to look more today at literal equations. And literal equations could be a formula, or it could just be an equation that involves several different variables. Okay, so a literal equation is a formula or equation that involves several variables. And the idea here, we want to be able to solve a literal equation for one of its variables. Okay, so they're going to get an equation that has multiple variables, and it's going to say, hey, solve for this one in particular. And we have to be able to use our methods of solving to do that. So the first thing we need to do, given a problem like this, is identify the variable term that we're trying to solve for. What's the letter that we're trying to solve for? Second step is we have to get that variable term isolated on one side of the equation by itself, just like we always do. And then the third thing we have to do is make the coefficient of that variable term become a 1. Okay. And we've done all this before. It's going to be, it was more specific before because we would solve to get an answer like x equals 2. Now we're not going to get a clean answer like x equals 2. We're going to get a variable in our result. And I'll show you what it looks like. So for example, solve for the specific variable. In this case, they're telling us to solve this equation for m. So m minus 10 equals n is our given equation. We want to solve for m. Okay, so I kind of highlighted our darkened in our variable term that we're solving for. So our objective now is we want to get m on the left side of the equation by itself. Okay, so how do I get the variable term isolated? I'm going to add 10 to both sides. Okay, minus 10 plus 10, that's 0. N plus 10 is n plus 10. Okay, so we're going to wind up with m equals n plus 10, and we're done. We've isolated the variable they've asked us to isolate, so m equals n plus 10. There's my solution right there, m equals n plus 10. That's all we got to do. Okay, solve this one for c. There's my c right there. So I have, p equals a plus 4 plus c, and they want us to get c isolated. Okay, the first thing I'm going to do is switch side or use the symmetric property to flip the sides of the equation. I like to solve left to right. Okay, so my c is now on the left, and I want to start working to isolate it. Okay, it's a plus 4 plus c. So we have addition here. So I need to make these guys 0. So the first thing I'm going to do is subtract an a from both sides. A minus a is 0. That will eliminate this. And over here I got p minus a, and that's just, we leave it as p minus a. Okay, so now once I eliminate the a, from the left side I have 4 plus c equals p minus a. Okay, again, our objective is to get c by itself. So since 4 is added to it, we're going to subtract 4 from both sides. 4 minus 4, that's 0. That's going to get c by itself, equals p minus a minus 4. I just add another minus 4 on the end of it, and there's our solution. C equals p minus a minus 4. Okay, right there. Okay, this one, a little different, but again, we're asked to solve for w. Right there's the w. So if I switch it, I just like to have my variable that I'm solving for on the left. 9w equals a. I want to isolate w. Okay, so since w is being multiplied by 9, that means I need to get this. I guess I should say, the 9w is already isolated. I need to make that coefficient become 1. So how do I make the 9 become 1? I divide by 9. So if I divide the left side by 9, I got to divide the right side by 9. Now, this 9 and this 9 are going to cancel to give me a 1, and w equals a over 9 is our answer. Don't have to do anything with a over 9, right? That's an answer right there. Okay. Solve for n. D equals 5m plus 11n. First thing I like to do is get the variable term I'm solving for on the left. Okay, so I'm trying to solve for this n right here. So n is, 11n is our variable term. Okay, that's what we need to isolate first. I got to get this 5m out of here. I got to eliminate it. Okay, so we got to isolate our variable term by eliminating this. So I'm going to subtract 5m from both sides. 5m minus 5m, that's 0. Okay, I'm going to get 11n equals d minus 5m. I can't do anything with d minus 5m. They're not like terms, so we just leave it as an expression. Okay, now I got my 11n isolated. Now I got to get the n by itself. So this coefficient of 11 I got to make become a 1. I do that by dividing each side by 11. Now notice, guys, I don't divide the d or the 5m by 11. I divide d minus 5m by 11. This is a quantity. That's all going to get, this answer is going to get divided by 11. You got to write it like this. Okay. Now the 11 here is going to cancel to give me a 1. And this I'm just going to leave like this. N equals d minus 5m. This is a quantity divided by 11. Okay, so a little bit more challenging there. Solve this one for y. All right, I got c equals 4 times the quantity of y plus k. Notice the 4 is not just the coefficient of the y. 4 is being multiplied by both these, the sum of these two. Okay, now what we can do here is, because 4 is being multiplied by the quantity, is we can divide each side by 4 to start with. Okay, 4 multiplied by the quantity, I can, since it's multiplied, I can cancel that 4 with that 4, and that will now give me just y plus k equals c over 4. Okay, the 4 is canceled. That leaves me with y plus k equals c over 4. Now we're trying to solve for y. Okay, y is right here. I want to get it by itself, so I got to eliminate this k. So I'm going to subtract k from both sides. K minus k is 0. So y equals c over 4 minus k. And that's my answer. I leave it like that. Okay. Another one similar to this one. Okay. So, whoa, I jumped a whole bunch up there, didn't it? So a equals 3/4 times the quantity of b plus c. All right. So the first thing I did was interchange the two sides. Okay. So 3/4 times the quantity of b plus c equals a. Notice I'm trying to solve for this b, and it's inside this parenthesis. All right. So this quantity is being multiplied by 3/4. So I want to make the 3/4 become 1. So the way I do that is multiply each side by 4/3. Okay, so 4/3 times 3/4. The 4's cancel, the 3's cancel. It leaves me with 1 times the quantity of b plus c, which is b plus c. And on the right side, I multiplied a by 4/3, and I just left it that way, 4/3 times a. Now I want to get b isolated. It's got plus c, so I got to get rid of that plus c. So how do I do it? I subtract c from both sides. C minus c is 0. So b, which we're solving for, equals 4/3 times a minus c. Okay. Last example here, E equals 32GH. We want to solve for G. Okay. So there's the G I'm solving for right here. Now, when you look at this one, this is a product. This is one term. It's 32 times G times H. And I'm trying to isolate the G. So what we want to do is divide by 32H on each side. Okay. This is a product. This is a product, which means we can cancel. So 32's will cancel to give you a 1 and a 1. The H's will cancel to give you a 1 and a 1. So you're going to be left with G. So G is going to equal E over 32H. And that's your answer. You've solved for G. You've isolated it. Okay. There's more examples on your McGraw-Hill textbook. All right. Your homework tonight's on ALEKS, and it's going to be just like the equations that I showed you in the examples. So if you need to go back through them, do so. Take a look at them, review them so you understand the processes that are being shown. All right. I'll let you get at it.